we have studied about resistance. We have learned that resistance is the opposition offered by the material to the flow of electrons. Now, let us consider a material and let us find out how does its resistance vary with the material properties. Now, it is found out that the resistance of a given material or a given conductor, for example, let us take a conductor of certain length called as L and certain area of cross section called as capital A. It is found out that the resistance offered by this wire is directly proportional to length of the wire. It is again common sense. That is because if the material is longer, the electron will face more opposition by the atoms, the material or its molecules. For example, if you look at these as the atoms or molecules of a given material, the more longer the material is, the more opposition the electron will face. So R is directly proportional to length, and also the resistance is inversely proportional to its area of cross section. That is because if you consider an area like this and a bigger area, when I say area, I mean area of cross section, the bigger the area is, electron will find more space to travel. Remember that resistance is the opposition which the atoms or molecules impose on the electron motion. If the material is more spacious, it is having more area of cross section, electron will find more space to move through it. Think of a case where we have a small area of cross section where these are the atoms position, and something of this kind where the atoms are little far away like this. So electron will find it more easier to travel through this region than through this region. So the bigger the areas, resistance will be smaller. It is what is found out experimentally. If we combine these two together, then we can say that the resistance is directly proportional to length and area of cross section. The next step would be to bring in a constant of proportionality. We can say from here R is equal to some constant of proportionality that is called as rho. This is called as rho, which is a Greek alphabet, L by A. So this rho is called as resistivity. It is not resistance, it is resistivity of the material, which means for a given conductor, for a given material, resistivity is constant, not resistance. Which means if we take a copper wire, for example, doesn't matter how long the wire is, whether it's wire is smaller or bigger or area smaller or bigger, resistivity will not change. So for a given material, resistivity is constant while R will change. The resistance will change based on the material type, based on material length and area of cross section. It is something like density and then mass. Think of material whose density will not change at all, but its mass will change. Similarly, you can think of resistivity to be something like density, while the resistance is something like mass. If we rewrite this, then from here what we get is we get rho is equal to Ra by L. This is what is the form for resistivity. Again, keep in mind that resistivity doesn't depend on these factors. It is constant for a given material. If we make both A as one unit and L as one unit, which means A is being made 1 meter square and length is 1 meter, then rho is equal to R mathematically, because physically it is not possible. So rho is equal to R mathematically. So we can define saying that resistivity is the resistance offered by material of unit length and unit area of cross section. So when we make both A and L as one units, then rho becomes resistance. Again, from here, if we find its SI unit, then it will be ohm, which is the SI unit for resistance, meter square by meter. From here we can cancel 1 meter, so it is finally ohm meter. So the SI unit of resistivity is ohm meter as given here. Verify and find its dimensional formula. In a similar way, we can define a term called as electrical conductivity. The common sense, we could say that this conductivity, which is denoted by sigma, this would be the inverse or reciprocal of resistivity. Resistivity tells us how much resistance will be offered to material, and conductivity tells you how much free it can move. It goes inversely. So you can say conductivity is the reciprocal of resistivity. So from there, what we get is, we get sigma is equal to A by rho L. Rho unit was ohm meter. If you read as this, it becomes ohm per meter. So it becomes like this, per ohm per meter. It becomes per ohm per meter, and this is called as mho, because the inverse of ohm would be like mho. It becomes mho per meter. We wrote this as ohm. Its inverse is something like this. So it is written as mho per meter. So this is the SI unit of electrical conductivity. Now, if you want to understand its significance, then we can think of two kind of materials called as conductors and then insulators. Now we can define whether something is conductor or an insulator based on either conductivity or resistivity. By common sense, we can tell that conductors are materials which will have higher conductivity. So conductivity for conductors will be more than conductivity of insulators. In terms of resistivity, we can say resistivity of insulators will be more than resistivity of conductors. So the properties like conductivity or resistivity helps us to differentiate whether a given material is a good conductor or a bad conductor.